In this lesson, we are going to solve this question I have on the screen. The question says that the front wheel suspension of an automobile is shown below. The pavement exerts a vertical force of 2,700 newtons on the tire. Determine the internal forces on the surface perpendicular to the horizontal and midway between C and D. And then we've been given a hint that the member CD is a two force member, which means that it is being acted upon by what two forces only, and then these forces are what axial forces. Okay, so that's what this means. So that's the hint we were given. So now let's look at this question here. So I have my free body diagram for the system here. Okay, so I'm going to explain the free body diagram. The 325 millimeters here was gotten by summing up the 200 millimeters and the 125 millimeters. Then over here too, I have the 150 millimeters here, which I have here. That's from the center of the tire to point C. And also I have FCD here, okay, which is the force that will be acting at what point C. Okay, the direction was assumed, so you can choose any direction you want. Your answer will tell the actual direction. And then over here too, you have the force at what point B here. The direction was assumed also. And then this force is at an angle to the horizontal. Okay, so it's going to have what an x and then a y component. That's what this bx and then this by that I have over there. And then I have the 2,700 newton force, which is being exerted on the tire by the pavement. That's the free body diagram. So now let's look at how we are going to answer this question. To do this, you are going to apply the equilibrium conditions to the system here. Okay, so you are going to have the sum of the forces in the x direction to be equal to what? 0. Right, so for the x direction, you have what? Bx and then FCD. Bx is acting the positive x direction, and then FCD is acting the negative x direction. So this should be equal to what? 0. Let's name this equation 1. Then I'm going to have some of the forces in the y direction also, and then that will be what? I have the 2,700 newton, which is positive, and then the Py, which is what? Negative. Sorry, the By is also positive because it is pointing upwards. So let's take note of that. So that will be plus By. Okay, it is positive, it is pointing upwards. So that will also be equal to what? 0. Let's name this equation 2. So now we are going to take the moment. Okay, so we're going to take the moment about what? Point B. Okay, so let's take note of that. When you take the moment about point C, you will not be able to find FCD because you already have two equations with three unknowns here. So when we take the moment about C, then you will not be able to find FCD. So now for that reason, let's take moment about what? Point B. So some of the moment about point B. Okay, taking the counterclockwise direction to be what? Positive. Okay, so this should be equal to the moment of the 2,700 newton about point B will be a clockwise moment. Okay, and that will make it what? Negative. And then its perpendicular distance from the point B is what? The 150 millimeters. So we are going to have minus 2,700 times the 150 millimeters. Okay, and then plus that of the moment of what? FCD. That will be a counterclockwise moment. Okay, that what? A counterclockwise moment. So that will be positive. So its perpendicular distance from point B is also 325 millimeters. So I'm going to have FCD multiplying with 325 millimeters, and then Bx and By are acting directly on point B, so they won't cause any moment. So you are going to have this to be equal to what? 0. So let's name this equation 3. Okay, so now from equation 3, we can solve for FCD, which is what? The force that we need. So let's look at how you are going to do this. So we are going to have 325 FCD to equal to what? 2,700 times what? 150, then that what? 405,000. So I'm going to divide both sides by 325. Okay, so this will cancel out this. Then you're going to have FCD to be equal to 1246.2 newtons. Okay, so this will be our answer. But looking at the answer we got, it is a positive value. Okay, it is a positive value. Then choosing the direction, we chose it to be in the negative x direction, but our answer is giving us what, a positive value. So that tells us that what our direction is wrong. So we can now come and change the direction. Okay, we can now come and change this direction here. So this will be the direction actually. Okay, so we have this here. So now let's go ahead and then draw the free body diagram for the member CD, which is the 2 force member. So let's do this. Okay, so we know that the force FCD equals 1246.2 newtons, and then look at its direction, it will be what, compression. Okay, so let's indicate it here. Okay, so I'm going to draw the 2 force member CD here. Okay, so this is the 2 force member CD that I have here. This is point C, then this is what, point D. Okay, and then I have the force FCD acting here, and then there will be another force which is equal but opposite in direction to what, the FCD. So that also act here. So it's that this force member is what is under compression. Then you have to make a cut midway and then perpendicular to what, CD. So I'm going to have the cut here. Okay, I'm going to have the cut here. So after making the cut, you're going to have a surface there. Okay, and then there should be a reaction there. Okay, there should be what, a reaction there. So what's the value for this reaction? So looking at this member CD here, which is what, a 2 force member, you'll see that what, all the axial forces on the cross sections will be the same, right? The axial forces on the cross sections will be the same because it is what, a 2 force member. Okay, so the reaction that will be here, okay, will be the same as what, this value FCD here, just that it will be in what, opposite direction. So therefore the internal forces on the surface perpendicular to the member CD, okay, will have the same value of what, 1246.2 newtons. So let's say we name this as what, N sub C. Then I'm going to have N sub C to be equal to 1246.2 newtons. Okay, and then because of the direction, it will be what, negative.